Hey, hello everyone. Good morning, good evening. Welcome to AZ Cloud Web. So today we are going to see an interesting topic: Azure Data Factory Integration Runtime. So in Azure Data Factory, this is a first step. So we should be aware before creating anything. So let's take a look what is actually integration runtime. The previous session, I we have seen the overall flow, or so what are all the prerequisite needed before creating a pipeline. Today, we are going to deep dive into an integration runtime. Here, so before getting into the integration runtime, we should be aware of what is linked service and what is activity. I hope everyone knows what is link service and activity. If any one of you doesn't aware, please go and see my previous video. So I have explained what are all the high level thing, what is link service, what is activity at a high level. So please go and see that video and come back to here. So basically, as we all know, the link service is equivalent to a connection string. So basically, it is used to establish a connection to a data store. So that's a linked service. So what is activity? So activity is nothing but a task. So if you have a big task, you can able to break it down into your multiple subtasks, correct? So like same setup, the activity is equivalent to a subtask. It is a only one task, okay, that is equivalent to a one activity, right? Okay, so link service is equivalent to a connection string, and activity is equivalent to a subtask or a task, we can say. So integration runtime. So IR acts as a bridge between the link service and the activity. I hope maybe you literally get some confusion. I'll explain you clearly. So IR is nothing but a compute environment. So it's basically a compute power. So in a layman term, so IR acts as a bridge between the link service and the activity. So here IR provides an compute power to perform the task. So basically, if I want to extract the data from one source and I want to push into another destination store, that if that is my use case, what and all I need. First step, I want to connect to my source, and then I want to extract the data, and then I want to push into a destination store. This is a three-step process, right? So first, for connecting a source, I need a link service. Yes, I have a link service. After connecting a source, you need to pull the data, correct? For pulling a data, you need some compute environment behind the scene, correct? So that processing power. So that is what we are saying as an IR. That is why the IR needed to do some kind of stuffs, okay, at a source side or even at a destination side. If we want to do some kind of things behind the scene, that compute power is provided by the integration runtime. So that's why we are calling, even if you connected to a source, okay, after connected to the source, just connecting the source is not enough. After you connected to the source, you need to bring the data. Once you bring the data, you do a transformation on top of the data. Once the transformation is complete, you again push into the destination store, right? So for these setups, IR acts as a bridge between the link service and the activity. Actually, this kind of transformation, who is going to do? Activity is going to do, right? So each and every activity is responsible for doing their task. For doing the task, what is required? Data is required, and also for a task, a compute power is required, right? It needs some kind of memory. It needs some kind of vCore to perform the task, right? So this kind of compute environment is provided by the integration runtime. So that's why IR acts as a bridge between the link service and the activity. Okay, the first question is answered. What is IR, right? I hope everyone is clear. So coming to the next question, what are the types of data integration? So basically, first we know what is IR. Then we should know how in what are all the scenarios, in what are all the integration data integration types. Does my IR supports or not, right? So these are all the simple things that we should be aware before designing a pipeline. Okay, like if you don't know these background concepts, and if you're designing a pipeline, in some way you will get confused in between. So that's why it's literally we should be understanding these concepts. So basically we understood what is IR. Next thing, we are going to see what are all the data integrations types, right? So where IR data integration, where IR capabilities can be utilized. Okay. So first there are four types. So we can segregate as a four type. This is not actually a types. I can't say. So this all the four scenarios where data integrate where integration runtime can be utilized. Okay. One is data flow. Second one is data movement. Third one is activity dispatch, and fourth one is SAS package execution. I hope most of the person, 80% of the person knows about this SAS package execution. So let's see. We are talking about the Azure integration runtime. We are talking inside Azure. Okay. So that's why. So first, let's take a data flow. I hope if anyone is new to the data factory, they don't know what is data flow. So basically, as a beginner, they just understand data flow is for transformation. If you want to do any kind of transformation, then data flow activity you can utilize. It is also a kind of activity. Okay, it is also going to do a task for you. It will but it is specialized in transformation task. For doing a transformation, as I said earlier, IR will be required. Without IR, you cannot able to do a transformation. So there are few types of there are few internal types of IRs is there. So if you take a data flow, a separate IR is required, which we call as a data flow runtime. Okay, that will that so if you want to do extract the data and transform, sorry, if you want to do extract the data and I don't want to do any transformation. Without transformation, if I want to push the data into destination, then copy is more than enough, right? You are just copying a data, copying from one place and put it to another place. This is just a copy. For this, copy activity is enough. Okay, for this copy activity, it's a certain type of IR will be supported. Okay, IR we can utilize. But if we need any transformation, we need additional IR, right? We need additional compute power because we are going to handle in a row based. Okay, who knows? If we certain people will work in thousands, a certain people work in billions, a certain people work in megabytes or terabytes of data, right? Who knows? So according to their data's transformation, of course, there is a separate data flow runtime is there. We need to configure for a data flow. So next come to a data movement. So data movement, for a data movement, as I said, it is just a copy activity. We can use it direct. We can utilize the common IR. Okay, I can say common IR. I can say data flow IR. So for a data movement, common IR can be utilized. The coming to activity dispatch. So what is activity dispatch? You know what is activity? Is it a task? Correct. So basically in a pipeline, okay, so you can able to connect to a database, you can able to connect to a big data database also, right? You can able to connect to a n number of databases, right? Or even n number of sources, I can say. Okay, so suppose if I'll take a database as an example, so everyone can relate very easily. So if I write a query, select star from table. So what I'm going to do, I'm going to have one activity or one task. I'm going to, I'm just saying that you go to the connect to SQL server and just execute the query. So here where this compute power comes in. So basically I'm just writing a query in a data factory, and I'm connecting to a database, and that query where it is executed, it is executed inside a database engine. So that is not related to a Azure IR. Okay, it's not related to this IR. So basically the actual workload is happening on the other side. It's not happening in here, right? So that's why we will just dispatch the activity, but we the compute power automatically taken care by the destination data store. So that is what activity dispatch. And next, coming to an SSIS package execution, as you all aware of that, what is SSIS, what is a package, and for executing a package, what is required? Obviously compute power is required, right? So for all of these categories, we can utilize our Azure IR. Okay, Azure IR, I mean the IR which is in the data factory. Okay, we can create an IR. We can satisfy all these categories. We can do all type of these task. So that is what no the categories comes to our place, right? Okay. So second question is answered. So coming to a third question. So here the place we are going to see what are all the types of IR. So far in a second, don't get confused with the two and three. Two is just we are segregating a type of work, and we are seeing whether IR in the data factory can have a capability to do that or not. Coming to a third point, actually we are having a actually we are going to see a types of a here is the actual types of IR. So there are three types of IR. One is Azure IR, second one is Azure SSIS IR, and third one is self-hosted IR. There are three types of IR. Okay, one is Azure IR, second one is Azure SSIS, and third one is self-hosted IR. Okay, so what is Azure IR? And we will be seeing what is an Azure IR, and when and all we are going to use an Azure integration runtime. Okay, first Azure IR is a managed and scalable IR which fully managed, and it is fully scalable. Scalable in the sense it can auto scale. It is, and also it is a serverless. Okay, so these are all the highlights of Azure IR. It is, we need not to worry about managing the compute power. Okay, and we not to worry about the scaling up or scaling down. That task, and also we need not to worry about the things, the auto scale. Right now I said it scale up and scale depending upon the demands. Depending upon the demand, it will auto scale, and it is auto scale up and auto scale down. Okay, and it is a serverless in the sense whatever the compute power you are utilizing it. So for that you are going to pay for that. So if you are not running anything, if you are not utilizing anything, don't pay. So that's the concept of serverless. So that is a beauty of an Azure IR. Okay, and when we will be using the Azure IR. So if you want to play around, basically the first point is Azure IR is mostly a public endpoint. It's mostly used for a public endpoints. It is not so restricted. It can connect to any public endpoints. Okay, that is a beautiful thing of Azure IR. But here when a company is adopting the Azure Data Factory or IR, they are not interested to publicly doing the things, public cloud, correct? They want their own stuff. They want to expose. They don't want to expose their own stuff to the public, right? So here we can satisfy those scenario in Azure IR also. Since Azure IR is can able to connect to all public endpoints, there is no outbound communication control in Azure IR. So, but we can add one more layer on Azure IR to have this capability. So, how we can do that? Everyone knows what is virtual network, correct? Every company have their own virtual network, correct? They will do all the things inside a vnet. They don't want to go outside a vnet, correct? They should have all the data inside a vnet. they have all the data. They want to do migration, so they want to do data transformation or data migration, anything, pushing, pulling, anything, whatever we are doing, that should be inside the managed virtual network, correct? So same thing, so you can create an Azure IR inside your managed virtual network. So by doing this kind of setup, you can able to control your outbound communication. Okay, so who is so basically, like if you take like there are two types of protocol we have, right? HTTP and HTTPS, right? So if you are in the managed virtual network, managed virtual network, so HTTPS will not be allowed in a public network, right? If you suppose in your company itself, if you are trying to reach any application which is having a HTTPS, okay, it is not allowed because you are in the managed virtual network, correct? So, so these kind of outbound communication can be controlled by using an Azure IR. So coming to one self-hosted IR, I talked about the virtual network, correct? I talked about the private virtual network, correct? So if you want, if anything is realized in the private virtual network, okay, and you want all your control, okay, all your thing, okay, if you want all your no all your point A to point B moment, if you want to watch all the moments, and if you want to do a scale up and scale down by yourself, okay, you don't want to manage your thing by the Azure, okay, suppose Azure, in the sense, even though behind the scene they are managing it, but we have some more control, okay, on our IR. So if that is the case, you can go for a self-hosted IR. Basically it is mostly for an on premises. Okay, if you have on premises, and if you have a virtual network, virtual private network, then if you want to go for an implementation of Azure Data Factory solution, then of course you will go for a self-hosted IR. So coming to a third one, Azure SSIR. So Azure SSIR, as the name implies, it will be used for lift and shift your SSIS workloads. Okay, so basically today, if you see, like most of the companies are migrating to a cloud, they have their own SSIS implementation in their company, right? They already doing the ETL or ELT things in their company. They want to bring those workloads into an they want to basically they want to utilize the compute power, but they want to do the same task, but behind the skin they want to utilize the compute power of an Azure. So that's the beauty of an Azure SSIS IR. Basically, for running the SSIS, Azure will be providing an IR to you. Compute power will be providing by the Azure, and you are running your workloads on a cloud. But still, you are inside the VNet. Okay, that's a Azure SSIS IR. So there are few other situation, like so basically these are the three main types of IR. So we need to be very careful while picking an IR and while doing the things, depending upon the data sources. Okay, so if your data source is from on premises, if your data source is from cloud, so if it, what is your destination data store, so where it is realized, so these are all the categories, these are all the attributes you need to consider before deciding an IR. So basically, it is always good to go with the self-hosted IR because it will come under, or you can able to manage it. Okay, so Azure IR is also manageable, fully manageable, and it are fully auto scalable. Okay, so but the one point is it can be publicly connecting to the all endpoints, right? It allows that one, it allows. Okay, but we can able to control that one by creating inside our vnet and all, and those things and all. But it's always, if you consider the security and safety, it's always good to go with the self-hosted IR. And seventh question. So, what is IR region? Yes. So, IR region is very important in integration runtime or a compute whenever you are provisioning the compute power. Region is very important. That's where your performance and your scalability and everything will relies on the where you are going to create an IR, where your IR is residing. Okay, so basically there are a few differences between these three IRs is there. Okay, when you take up an Azure IR, it is auto managed. Okay, so we do have a auto resolve integration runtime also in Azure Data Factory. So the beauty of that one is, suppose so we will talk about a few cases. So we will take a simple example. Suppose your source data relies, okay, your source data is in the SQL database. Okay, SQL database, Azure SQL database. Okay, the Azure SQL database was in the East US region. Okay, East US region, and and also I want and my destination also a SQL database that is in the same region, East US region. Both are in the same East US region. Okay. Now I want to design a pipeline to migrate a data between these databases. So you understood both databases, okay, source and destination databases created in the East US region. So I want to design a pipeline to migrate a data between the databases. So now what I'll do, I will create my IR, okay, in the same region, East US region. Since I don't create my IR in the West US region or any other region, because IR needs to IR should be closely, it should be closest, it should be in closest region of your source and destination data store. Okay, so that's where your activity runtime, okay, will get reduced eventually. If you have an IR in West US but your source and destination are in the different region, then automatically consider that. But basically, if you want to do a single task also, compute power is needed. Your IR is in the different region, the source and destination on the different region. So if the three needs to be connected, interrelated, so it takes time, right? So that's where, while before creating an IR, we should be very careful while selecting a region, and we should be aware of where my data store relies. If it is an on-premises, yeah, most of the cases the data relies in the on-premises, right? That time self-hosted IR, you can install your self-hosted integrated runtime in your virtual machine that relies inside the VNet. Okay, so that's how we need to decide. Before creating an IR, we should be very careful about region, area of creation. And I also say that, right, the auto resolve integration runtime. The beauty of auto resolve integration runtime is that um, it automatically picks up the closest region where your destination workload is happening. Suppose my destination store is at the West US region. Okay, I don't auto resolve integration will automatically predict, automatically manage as closest region as possible. Okay, it will pick the IR wherever near to the West US. It will pick the IR and will do the job near to the East US. So like that, where my destination store is there, my auto resolve IR will automatically detect, and it will pick the IR, and whichever is closest to my destination or a source data store. So that's the beauty of an auto resolve integration runtime. So, and coming to the eighth point, so how to determine and when to use which IR. So this is what we discussed, right? So based on the source and your destination data store, we should be picking the IR. And coming to the ninth point, so I'm talking about the compute, right? Compute. So compute, so in by which measurement I will measure my compute. Okay, you will be measuring by data integration unit. So that's why we will call as a DAU. Okay, DAU is for copy activity. Okay, so basically data integration unit in the sense it can be given to 486 until 256 you can give it. And also even you can automatically scale up and scale down by using some type of Azure functions depending upon the workloads. You can calculate the number of rows, you can scale up depending upon the demands, and you can scale down. So this kind of task you can do that. But DAU is DAU is basically okay, this many DAUs I needed. Okay, like that you can decide it, and you need to set up for your copy activity. So if it is a data flow, as I said, for a data flow, you need to configure you need to do a extra one layer configuration that is called data flow runtime. So you need to pick a compute size basically. So four plus four. So basically, Dataflow is behind the Apache Spark cluster. It works behind the scene of Apache Spark cluster. So it's a kind of worker and driver node. Okay, you need to pick a machine where it is having a good configuration, like depending upon the V code. As of now, you can understand it is a V code. We are picking the V code. Okay, I hope everyone knows V code, right? Like basically, it's a combination of memory, storage, and IOPS. Like you need to decide and you need to pick depending upon your workload. So that's how we need to measure our compute size. Okay, so and coming to the 10th point, as I said, data flow runtime configuration is separate, so we need to configure in terms of vcores. Okay, and so this is all that this is what I need to communicate about the integration runtime. So this is what integration runtime actually. So next session we will see about the linked service. Okay, so first we should be aware of what is IR. So if time allows, what I'll do, I'll go and show you. Uh, Here's my data factory. I'm going to, yes, you're going to a management hub. I'm in the management hub. Integration runtime is there. This is auto resolve integration runtime. As we discussed, it is auto scale, and also it is not okay. And also it will pick the region as close as possible. So this is the types of IR: Azure IR, self-hosted IR, Azure SSIS IR. If you click here and click on continue, it will ask you whether you want to do create Azure IR or a self-hosted IR. As I said, self-hosted IR is mostly suitable for on-premises or a private network workloads. If you want to do a cloud movement, okay, as I said, Azure IR is a fully managed serverless compute in Azure. Okay, and this is extra thing you need to do that if you go for a self-hosted IR. Okay, as of now, I will go for Azure IR. I'll show you how the DA use everything. Virtual go to virtual network. This is a time to live. I'll talk about this one and enable copy. Yeah, this is where your DA use relies. Okay, so this is where you need to set the copy power. Okay, basically it is a copy power. Okay, based on this, if you have to, if you are in a situation of copying a number of rows, okay, megabytes or terabytes of GB of load, then you should be go for a maximum DAU. Okay, that's how you can scale up and scale down. Okay, this is our time to live. Time to live is nothing but like it is. They have decided. They have came up with the solution to avoid the extra cost. Suppose if you taken up a 256 DAU, and if you are not using okay, if using for a 1 hour you left it, and you are not using, means automatically within a 5 minutes of ideal time it will like it will shut down. Basically it will shut down, not shut down, like since it is a serverless, whenever you need it will allocate you, whenever you are not using it will deallocate you. That's it. This is what I'm talking about, a data flow runtime. We need to configure specifically for data flow runtime. You can configure like this compute size. You can go for a large. If you want to do a custom, you can also do that. Okay, there are certain types that we will discuss about when we are seeing up the data flow. So as I said, for driver and worker node, 4 plus 4, 64. You can go up to 256.